From the Earth to the Moon. Chapter 9. The Question of Powders. The question of powder still remained to be settled. The public awaited this last decision with anxiety. The size of the projectile and length of the cannon being given. What would be the quantity of powder? This terrible agent, of which, however, man has made himself master, was destined to play a part in unusual proportions. It is generally known and often asserted that gunpowder was invented in the 14th century by the monk Schwartz, who paid for his great discovery with his life. But it is nearly proved now that this story must be ranked among the legends of the Middle Ages.
Gunpowder was.
It is a direct product of Greek fire, composed, like it, of sulfur and saltpeter. Only since that epoch these mixtures, which were only dissolving, have been transformed into detonating mixtures. But if learned men know perfectly the false history of gunpowder, few people are aware of its mechanical power. Now this is necessary to be known in order to understand the importance of the question submitted to the committee. Thus a liter of gunpowder weighs about 2 pounds. It produces, by burning, about 400 liters of gas. This gas, liberated, and under the action of a temperature of 400 deg, occupies the space of 4,000 liters. Therefore their volume of powder is to the volume of gas produced by its deflagration as 1 to 400. The frightful force of this gas, when it is compressed into a space 4,000 times too small, may be imagined. This is what the members of the committee knew perfectly when, the next day, they were sitting. Major Elphinstone opened the debate. "My dear comrades," said the distinguished chemist, "I am going to begin with some unexceptionable figures, which will serve as a basis for our calculation. The 24-pound cannon ball, of which the Honorable J.T. Maston spoke, is driven out of the cannon by 16 pounds of powder only." "You are certain of your figures?" asked Barbicane. "Absolutely certain,"
answered the major.
"Uses 75 pounds of powder for a projectile of 800 pounds, and the Rodman Columbiad only expends 160 pounds of powder to send its half-ton bullet 6 miles. These facts cannot be doubted, for I found them myself in the reports of the Committee of Artillery." "That is certain." "Well," resumed the major, "the conclusion to be drawn from these figures is that the quantity of powder does not augment with the weight of the shot. In fact, if a shot of 24 pounds took 16 pounds of powder, and,
in other terms,
if in ordinary cannons a quantity of powder weighing 2/3 of the weight of the projectile is used, this proportion is not always necessary. Calculate, and you will see that for the shot of half a ton weight of powder, this quantity has been
reduced to 116 pounds
only." "What are you driving at?" asked the president. "The extreme of your theory,
my dear major,"
said J.T. Maston,
"would
bring you to having no powder at all, provided your shot were
sufficiently heavy."
Friend Maston will have his joke even in the most serious things. But he need not be uneasy. I shall soon propose a quantity of powder that will satisfy him. Only I wish to have it understood that during the war, and for the largest guns, the weight of the powder was reduced, after experience,
to 1/10 of the weight of
the shot. Nothing is more exact. But, before deciding the quantity of powder necessary to give the impulsion, I think it would be well to agree upon its nature. We shall use a large grained powder,
answered the major.
Its Deflagration is the most rapid. No doubt, replied Morgan. But it is very brittle, and ends by damaging the chamber of the gun. Certainly. But what would be bad for a gun destined for long service would not be so for our Columbiad. We run no danger of explosion. The powder must immediately take fire to make its mechanical effect complete. We might make several touch holes, said J. T. Maston, so as to set fire to it in several places at the same time. No doubt, answered Elphinstone, but that would make the working of it more difficult. I therefore come back to my large-grained powder that removes these difficulties. So be it, answered the general. To load his Columbiad, resumed the major, Rodman used a powder in grains as large as chestnuts, made of willow charcoal, simply rarefied, in cast iron pans. This powder was hard and shining, left no stain on the hands, contained a great proportion of hydrogen and oxygen, deflagrated instantaneously, and, though very brittle, did not much damage the mouthpiece. Well, it seems to me, answered J. Maston, that we have nothing to hesitate about, and that our choice is made. Unless you prefer gold powder, replied the major, which provoked a threatening gesture from the steel hook of his susceptible friend. Until then Barbicane had kept himself aloof from the discussion. He listened, and had evidently an idea. He contented himself with saying simply, "Now, my friends, what quantity of powder do ye propose?" The three members of the gun club looked at one another for the space of a minute. 200,000 pounds, said Morgan at last. 500,000, replied the major. Exclaimed J. T. Maston. This time Elphinstone dared not tax his colleague with exaggeration. Fact. The question was that of sending to the moon a projectile weighing 20,000 pounds, and of giving it an initial force of 2,000 yards a second. A moment of silence, therefore, followed the triple proposition made by the three colleagues. It was at last broken by President Barbicane. "My brave comrades," said he in a quiet tone, "I start from this principle,
that the resistance of our cannon,
in the given conditions, is unlimited. I shall, therefore, surprise the Honorable J. T. Maston, when I tell him that he has been timid in his calculations, and I propose to double his 800,000 pounds of powder. 1,600,000 pounds, shouted J. T. Maston, jumping out of his chair. Quite as much as that. Then we shall have to come back to my cannon half a mile long. It is evident, said the major. 1,600,000 pounds of powder, resumed the secretary of committee, will occupy about a space of 22,000 cubic feet. Now, as your cannon will only hold about 54,000 cubic feet, it will be half full, and the chamber will not be long enough to allow the explosion of the gas to. There was nothing to answer. J.
T.
Maston spoke the truth.
They all looked at Barbicane.
However, resumed the president, I hold to that quantity of powder. Think. 600,000 pounds of powder will give 6,000 liters of gas. Then how is it to be done? Asked the general. It is very simple, keeping at the same time its mechanical power. Good. By what means? I will tell you, answered Barbicane simply. Nothing is easier, in fact, he resumed, than to bring that massive powder to a volume 4 times less. You all know that curious cellular matter which constitutes the elementary tissues of vegetables. Ah,
said the major.
I understand you. This matter, said the president, is obtained in perfect purity in different things, especially in cotton, which is nothing but the skin of the seeds of the cotton plant.
Now cotton,
combined with cold nitric acid, is transformed into a substance eminently insoluble, eminently combustible. Some years ago, a French chemist, Braconnet, discovered this substance, which he called xyloridine. In 1838, another Frenchman, Pelouse, studied its different properties. And lastly,
in 1846,
Schobbine, professor of chemistry at Bâle, this powder is nitric cotton, or pyroxyle, answered Elphinstone, or fulminating cotton, replied Morgan. Is there not an American name to put at the bottom of this discovery? Exclaimed J. T. Maston, animated by a lively sentiment of patriotism. Not one, unfortunately, replied the Major. Nevertheless, resumed the President, I may tell him that one of our fellow citizens may be annexed to the study of their cellulosity for collodion, which is one of the principal agents in being added, and it was discovered by Maynard, then a medical student. Hurrah for Maynard and fulminating cotton, cried the noisy secretary of the gun club. I return to pyroxyle, resumed Barbicane. You are acquainted with its properties which make it so precious to us. It is prepared with their greatest facility. Cotton plunged in smoking nitric acid for 15 minutes, then washed in water, then dried, and that is all. Nothing is more simple. Certainty, said Morgan. What is more, pyroxyle is not damaged by moisture, a precious quality in our eyes, as it will take several days to load the cannon. Its inflammability takes place at 170 deg, instead of at 240 deg, and its deflagration is so immediate that it may be fired on ordinary gunpowder before the latter has time to catch fire too. Perfect, answered the Major. Only it will cost more. What does that matter? Said J. T. Maston. Lastly, it communicates to projectiles a speed 4 times greater than that of gunpowder.
I may even add that if
8/10 of its weight of nitrate of potash is added, its expansive force is still greatly augmented. Will that be necessary? Asked the Major. I do not think so, answered Barbicane. Thus instead of 1,600,000 pounds of powder, we shall only have 400,000 pounds of fulminating cotton, and as we can, without danger, compress 500 pounds of cotton into 27 cubic feet, that quantity will not take up more than 180 feet in the chamber of the Columbiad. By these means the projectile will have more than 700 feet of chamber to traverse under a force of 6,000,000 of liters of gas, before taking its flight over the Queen of Night. Here J. T. Maston could not contain his emotion. He threw himself into the arms of his friend with the violence of a projectile, and he would have been stove in had he not have been bomb-proof. This incident ended the first sitting of the committee. Barbicane and his enterprising colleagues, to whom nothing seemed impossible, had just solved the complex question of the projectile, cannon, and powder. Their plan being made, there was nothing left but to put it into execution.